So a number of you have asked questions about problems where you have an exponential equation and you need to figure out the equation based on the graph. So the first thing we're going to need to do when we look at a graph like this is to decide whether it's exponential growth or exponential decay. So let me give you a couple of examples on the graphing calculator. So exponential growth might be something like, say, 2 raised to the power of x. And so with exponential growth, you can see the numbers are rapidly increasing and that um, it approaches the horizontal asymptote as values get smaller and smaller. On the other hand, we might have something like 1/2 raised to the power of x. And then we'll see that the horizontal asymptote is still at y equals 0, but as the x values get bigger and bigger, we get closer and closer to the asymptote. And so then this is called exponential decay to differentiate it from exponential growth. And so exponential decay is useful in situations like, for example, someone's ingested a drug and you want to know how long it'll take till it's out of their system, or radioactivity, like if you have some kind of radioactive source and you want to figure out when it's going to be safe to enter the room, how many minutes, hours, or even years it might be till it's decayed. So in this case, we're looking at a problem which is exponential decay. You can see that it approaches a horizontal asymptote as the x values get larger and larger. And so with exponential decay, the b value, or the base, is always going to be a number between 0 and 1. So in this example, we have 1/2. So that's between 0 and 1, so then it's decay. And we might wonder why it's decay. And so the reason is because if we have say we have something like 2 to the x, so that's 2 times 2 times 2, and so the number keeps getting bigger and bigger. But say we had 1/2 to the x, then we'd have 1/2 times 1/2, which is 1/4, times 1/2, which is 1/8, and so the numbers keep getting smaller and smaller as long as b is between 0 and 1. We'll always have a decay situation. And so the next thing we need to look at in our graph that we're looking at, so we can see that it's decay, and then we want to identify the horizontal asymptote, and in particular to see if it's not y equals 0, but if it's some other value. And so here we can kind of hypothesize that the horizontal asymptote is at y equals 1. And this is great because then when we switch back to working on our equation, so let's say we have f of x equals a times b raised to the x. Now, let's say that we pick a really, so we know that it's decay, so then as x gets larger and larger, then ab to the x is approaching 0. But in our problem here, it's not approaching 0. It's actually approaching y equals 1. And so what we're going to do then is edit our graph a tiny bit. We're going to add this plus 1. And if it were just at y equals 0, it would just be plus 0, and it would just vanish. But in this case, we have a plus 1. So now that we have the basic form of our equation established, we're now going to need to find two values on the curve. And ideally, you're going to want one of them to be at x equals 0. And you'll see why in a moment. So if we go to x equals 0, then we see that f of 0 equals 2. So we'll write that one down. And then if we go to x equals -1, we see f of -1 equals 6. And so we just need 2 points in order to find our exponential equation. So the first one we're going to start with is always going to be the x equals 0. And so what we're going to say is if f of 0 equals 2, then that means 2 equals a times b to the x, which is 0, plus 1. Now this is really neat because we have b to the 0, and anything raised to the 0 is just 1. So we'll say 2 equals a times 1 plus 1, or 2 equals a plus 1. Subtract 1 from both sides, and we get a equals 1. So that's great because now we've found what we need for a. We know a is just 1. And then 1 times b to the x is just b to the x. So that's great. So now we've got a figured out. Now we need to find b. Now we'll know if our b answer is correct if it's between 0 and 1. So let's see what happens. So now we take f of x equals b to the x plus 1, and we have b to the minus 1 plus 1 equals 6. So immediately we can see that we would take b to the minus 1 equals, subtract 1 from both sides, and we have 5. Now b to the minus 1, that's convenient because that is 1 over b equals 5. And now if we move the 5 to divide both sides by 5, multiply both sides by b, we end up with 1/5 equals b. And then we can come back up here, and we know that b is 1/5. And so then that's great because it is indeed exponential decay. We know that it satisfies both of our 2 points. And just to check, we can plug it into a graphing calculator. So we'll put in 1/5 raised to the x plus 1. And we see that we indeed have that curve that has the horizontal asymptote at y equals 1. It's exponential decay. And f of 0 is 2, and f of minus 1 is 6. And so then we have our answer, f of x equals 1/5 raised to the x plus 1. I hope this is useful, and let me know if you have any more questions. You can, as always, reach me through Google Hangouts or through a post on the discussion board. Thanks for listening to this video.